Hi, everyone. Welcome to another live stream of language design, heading for version 13.1 of Wolfram language. At least I think many of the things we're talking about here today will be in version 13.1. But this is part of our incremental language development series. Are we going to start on the first item here or the second item here?
Let's start with the second for now. There's a handful of things related to tree labeling and styling that we wanted to look at that are for 13.1.
Okay. All right. Where do I start?
If we just go down the list.
So one question is, why is this different from graphs? And you've explained some of that. So tree element label style. Well, let's see. Let's start off with tree element label. There is a tree element label, right?
Yes, added in 13.0.
Okay, so let me just understand that. So if I have a random tree of 40 elements, then I can say of this tree element label. Let's see if I know how to do this. Arrow x blank, let's say x greater than 10, arrow, I don't know, framed of x. And is this going to do what I think? Splatteroo.
Right. So the rules currently don't support patterns, but if they did, the left-hand side is a position spec for trees. So that's one difference with graphs, where the left-hand side is a vertex name.
Okay. Well, so if I say,
So what's happening here is you just specified the label for the root.
okay, but so they don't support patterns?
No.
Okay, well, they got to be the same as what happens with vertex labels, surely.
Well, the difference is that, like I said, that this is a position, the left-hand side is a position spec, not a vertex name, and we don't have vertex names.
But it's presumably it's still useful to be able to do things with patterns, like saying, every even numbered index, make it red or something like that.
Yeah, why wouldn't we support? I mean, otherwise.
No, what? So I mean, like this, like pattern and replacement thing doesn't work.
So what does work? What tree element label? What do I put?
The left-hand side is a pattern that matches a position spec.
And why can't X blank match a position spec?
I just haven't done the replacement part.
I don't understand. What would match a position spec?
I think the problem is that you're using X on the right.
Sorry, what? Wait a minute. What? What?
The position spec is a
right.
list of part
Is the issue that this is like replace part, so he needs to give a listy sort of pattern that matches? Right.
Okay, so what happens if I say X blank, comma, X blank, comma, triple blank goes to this? Anybody getting no? What the heck's going on? Nobody's getting framed here. Why not? I'm totally confused. What should I be seeing here? If I put an echo in
a regular rule.
I'm just irreducibly
rule instead of rule delayed.
But that's not going to work because it's going to evaluate the right hand side.
With yeah.
Right.
Well, now why does that have a rule delayed there? I'm just
because we're re-optioning the same tree a bunch of times.
Right. You wanted the percent to be the like %1 or whatever your original your tree
okay.
was.
Yeah. Okay. Fine. Now, why is it labeled with 1? Oh, because
because the X is 1.
Right. The X bound to 1. Right.
Why does it always bind to 1?
Because it's matching against the position. It's like replace part.
Oh, I see. I see. So if this was, okay, so if let's say it's this, and I said this and that, and I said slash semi x not equal to y, then it will be much jollier. Why is it matching 1 in those cases? Isn't that
Because the first one is 1, right? The x is 1 because they're all children of 1.
You'd say y, arrow framed of y or something.
Yeah, okay.
I'm surprised you can use the bound variables on the right hand side at all. I didn't even intend to implement that.
Right. Maybe if you delete the first blank again, we'll get something more interesting now.
I see. Okay, yeah, that makes sense. By the way, you might want to give examples like this in the documentation for tree element label.
Mm-hmm. And rule delayed should probably work.
Yeah, definitely.
Yes, it absolutely should. I mean, it's absolutely a bug that rule works, but rule delayed does not.
Mm-hmm.
Okay, so let me just understand. So tree element label, the left-hand side is this. Now, if I want to just say, okay, so tree element label style, whoops. Oh God, this whole business up again. Oh my gosh. So I've got to do the all arrow red, right?
Mm-hmm.
Okay. But now if I say all arrow, and then I say,
is there a good reason why if it's not a rule, why that isn't just an implied all goes to?
We would need a representation for just this node.
What do you mean just this node?
So all of these options specify the option for
a tree element.
Yeah, because tree and tree element are the same.
Position specs is actually, it causes like a cascading thing where lower options override the options from the parent.
Okay, so basically you're saying if you did tree element label style goes to red inside of a tree element, then it would
that particular one
would be red. Yeah.
So long as this is really a front and center top thing in the documentation for tree element label style, it's probably okay. But it really has to be. Now, how do I make the backgrounds, complete backgrounds, purple or something?
That's tree element style.
Oh, I see. So if I say, okay, so let me understand what this is. Do I say background arrow, whatever, or what do I say?
No, you just give a style.
Whoever's making that noise, could you stop, please? Okay. All right. Okay, so that's tree element style, tree element label style. Okay, tree element label function. Come on, I think, yeah. Anyway. Okay. Tree element label function. How could that be? Okay. Let's see. So what does that do? What is it? What are its arguments? Did we go through this before? I think we went through this before. What the arguments?
We skimmed over it, but we didn't look at each one individually.
Okay.
So
Danny,
the only argument is the data.
Sorry, what was that?
Well, you were believed to be making all kinds of background noise.
My thing said it was on mute. I just took it off.
Oh,
It should not have been me. If it is, I've got a real problem here.
Okay. Okay, sorry, back to Ian. What were you saying here?
So the function takes one argument, which is the data.
Why doesn't it take, okay, so I don't understand that. Why is it tree element label function? So it only takes the label. I don't understand. What is this doing? Is this making a label?
It's creating a label. By default, you use the data as the label.
But what happens if I want to draw all kinds of wild things in my nodes of my tree? How do I do that?
Either tree element label or tree element label function. Tree element label is if.
But why doesn't, I mean, tree element, if I want to draw graphics primitive, for example, don't I need to know what the coordinates are?
Not for the label.
Okay, but if I want to draw, look, it's vertex shape function.
Mhm.
Oh, I see. You've got a tree element shape function.
Yep, and a tree element shape.
What does tree element shape do? Because that's different from.
That's the thing where you just give it a graphics. Look at the basic examples.
But is there a vertex shape?
Yeah.
For graphs?
Mhm.
Am I misremembering? And there's a vertex shape function, which is what one typically uses, because vertex shape is just
Right.
a
You have to
fixed.
specify it for each one.
But not only do you have to specify it, don't you have to give?
Not for
The vertex-
vertex shape. Vertex shape, you just give the shape. Vertex shape
Okay,
function.
but if I want to
position and dimensions.
Right, but the thing that it gives out for vertex shape, how does it know where to put it?
The vertex shape function knows where to put it. And the vertex shape function will resize whatever you gave for vertex shape.
Okay, but if I want to, I see. So I have to put it in what coordinate system? Where's the center of the node? In other words, if I draw a picture of an elephant and I want the node to be at the position of its, the end of its trunk or something, how do I specify where in the vertex shape, which is the elephant?
I believe you would have to use tree element shape function for that.
Right. I presume this just centers your image on your graphics on wherever the quote unquote vertex is.
This documentation is inadequate. Avery, this is something we need to take up with those guys, please.
Okay.
It's not explaining this. It's just not saying. Growl. So what are you doing, Ian, in the case of trees? For tree element shape?
Tree element shape works the same as vertex shape, except for, the specification.
Okay, then tell me what it does. I mean, then does that mean you know what it does?
I mean, you specify the shape and then it uses that as the vertex shape.
I know that, but how big is it and where does it center it?
That's handled by tree element shape function.
Right. So there's an
element
auto,
shape
so what
is a
is
thing
the
that
automatic
auto-positions
value of
elements.
tree element shape function is Stephen's question.
Yeah.
I see. I mean, it's automatic.
I presume the default is automatic, and then what does that effectively do if you specify a tree element shape?
That is my question. Yes. What's the answer? How big is it? What? I mean, it's presumably then determined by tree element size.
Yes. And tree element coordinates.
Okay, but you need to be able to specify that here. Because tree element coordinates, look, there's a func here. Tree element coordinates is XY.
Yeah, there's a separate tree element coordinates option that specifies the value that would get fed into that argument there.
No, I understand that, but this is saying, for example, so you're saying that between the vertex shape, what isn't defined, there's one thing that isn't defined here. which is where is XY inside the picture of the elephant that is data?
I think you can use inset for that.
No, but where is it by default?
It's centered at the vertex coordinates.
No, I'm asking where in the elephant is it? Where is the
The center of the image, I would assume.
Okay, well, but this needs to be
Or the
documented. We
graphics,
need to understand
I
it and
think.
document it. I mean, you think it's the default behavior of inset? What is the default behavior of inset?
I don't think he's
I was saying
claiming
you
that
could use
it's.
inset to change the placement.
No, I understand, but it's probably implemented with inset, and it probably uses. I mean, it's not obvious what the center of the bounding box would be. I'm led to make some joke about whether the elephant is still in the room. But you understand what I'm saying. Where is the, as you put the picture of the elephant on that node, which part of the elephant is at the position of the node? Right, and you're claiming it's the center of the bounding box of the elephant image. Is that correct?
It seems to be the case. Yeah.
Okay, all right. So we should nail that down and document it.
Mhm.
And arguably, and we should also document in both tree element shape function and vertex shape function how to use inset to change that. It's completely not self-evident to me that this will work because
That may already be the case in the graph documentation. I'm not sure.
okay, well, we should check. But anyway, the point I'm making is there's a certain region that has been cleared for putting that vertex.
I don't think that's true. I don't think that's true. I think a vertex is, determined, and then, right, it puts something there, right?
Yeah, but the question is the arcs that are coming into that vertex, where do they get stopped? For example, if that vertex is transparent, if the vertex shape function is transparent, do the arcs show up underneath it?
Yes. That's the edge shape function, and by default we just use line.
Okay, but so you're saying if I make a transparent vertex shape function, okay, so here, for example, if I go here and I make the
or if you just make the
if you do tree element shape function, all goes to none.
Tree element shape all goes to none.
Shape function.
Why? Why isn't it just tree element shape all goes to none?
None is not a graphics or a region or an image.
Okay, all right. Shape function goes to none. That is a bit weird.
Right. So the labels are a little bit off of the
node
of the actual node, which I guess makes sense, right?
Well, I mean, in this case, let's just reduce.
So So if you use the automatic shape function, I center the labels inside the shape, which is not the default graph behavior. So if you specify a non-default shape function, then it uses the same label placement as graph.
Hey, hold on. Why is tree element size goes to 0 not working here?
Because these things by design do not resize when you resize the tree, so that you can shrink the tree without making the labels illegible.
At the cost of making your labels overrun each other.
Mm-hmm.
But I don't understand. Why wouldn't
that's only with the default shape function?
I don't understand. Why wouldn't tree element size just change the size? Okay, let's start off with something very naive.
Do tree of none real quick. Right? You'll want to resize that, or probably tree of data comma none. Put something in the payload. Right? Now you'll want to resize that.
Yeah.
Because by default graph has all this space.
Well,
My
that doesn't
claim,
look
my
like
claim
it.
is that if the tree element size function interacted with this, you now wouldn't be able to read that label.
I thought we were automatically cutting down this this size.
I think it's something Charles agreed to at some point, but I don't know what the status of the implementation is.
Okay, so that's a thing for Avery to go chase.
Got it.
Okay. Question here. Well, let's see. What are we talking about here? So you're saying that unlike vertex size, so if I make an unlabeled tree here,
Unlabeled tree takes a tree.
okay. Now, why isn't the vertex shape function, vertex size just working here, just like it does for an ordinary graphic?
For the unlabeled case,
Okay, why isn't that working?
that would be fine.
Why isn't that working?
If it hasn't been if it hasn't been documented yet, right? The coloring won't be.
No, I
right.
understand, but it isn't working either.
Oh yeah. Yeah.
That should
Unlabeled
work.
tree should take options, yeah.
Yeah, okay. All right, okay. But so I don't know whether I can do this. It might not work. Just say tree of unlabeled tree.
Well, should it, like, if you specify tree element label inside unlabeled tree, do you still get a label?
Label inside an unlabeled tree. Yes, sure.
Okay.
I think that's a reasonable thing to do. Okay, so where were we here? Is there something still not understood about tree element size?
Basically, the tree element size option only works with non-default shape functions and shapes.
Why? Why doesn't it work for the default in the unlabeled case? Why doesn't it determine the size of that node?
It could work in the unlabeled case. That's fine.
Okay, but in the labeled case, you are saying if we increase the size, that we shouldn't do anything. Well, wait a minute. What are we saying? You're saying in the case of graphs,
I'm saying in the
what does it
labeled
do?
case, I'm saying in the labeled case, we have a fixed size, which is just whatever the size of the data.
Okay, but I don't think that's right, because look at what happens with graphs. If we say vertex labels go to automatic here, well, actually, if we did that with placed, right, and put the A inside the node. Okay, so the issue is this.
Graph doesn't have a way to do what tree is doing in a straightforward way of like wrapping this around the label and using that size. I mean, that's what I'm doing for tree, but you end up with something that's just a fixed size.
I'm confused. Does anybody, like Christopher, you're a user of these things. Do you know what is the issue here? Is the issue that the placed in the center thing for graph is not being supported? Maybe we should try and get Charles here.
I'm saying placed does not interact with vertex shape.
Can we try and get Charles? But Christopher, do you have an opinion about this?
No, I mean, these things are always kind of mysterious to me. I mean, part of it is that there's sort of, I think everything is kind of inset-ish. Like it's all graphics within graphics.
Yeah. Well, I think what you've done here, Ian, is you've jumped beyond, you've gone to placed. You've got a thing where you're by default doing a placed inside the nodes of the tree. And therefore you have a bunch of different issues from graph, but the names of the options that you have are the same as the names of the graph.
Placed alone would just change where the label is.
I know.
It's also the shape itself depends on the label.
By shape, you mean the appearance of the node.
Yeah, like this is literally a framed of the label. So whatever size framed of the label is, that is the size it will use. And tree element size can't.
I get it. But you've done that. I mean, we could have a version of graph that just labels its nodes in this kind of very placed like this way. We don't have that right now. You can get to that point by setting a bunch of graph options.
Right. Which what I'm doing for trees is by having this shape function with a fixed size.
Right. Okay. So we need to get Charles and see what he has to say about this for graphs. Because I think, again, the question that I have design-wise here is that anything, if what you're doing here is always jumping beyond graphs with different name structures here, then we're all good. But if there's something like tree element size, where we would normally expect, you're saying let's hack.
I'm saying it's only a problem with the default shape function. I'm saying if you do any other shape or any other shape function, tree element size works exactly as it does, as vertex size does.
Hello.
Hi.
Hi.
We're looking at labeling in trees and graphs. Okay. And so Ian has a bunch of options for tree labeling that we are confused about the relationship to graph labeling. So in particular, tree element size for a standard labeled tree. I don't understand this at all. I mean, what is this doing, this case here?
This is an example of tree element shape.
No, but that's also got tree element size. What does the large do?
Change the size and see what it does.
Well, is the example here wrong? Because it doesn't show it as big here.
Resize it.
Well, that example is very confusing then. I mean, so
Well,
so
the
tree
size is well, actually, is there a way of setting the size with like scaled or something, or like how would you reproduce the behavior of the vertices here that are not resizing with the graphic? If you get what I mean.
So the shape function takes 3 arguments. One of them, the third argument, is influenced by the size. I'm not quite sure how, but it's influenced by the size. And I'm saying the default tree shape function ignores it. It just renders the shape as framed of the label.
Charles, can you comment on that? Because you've got a vertex size that is set externally, so to speak. Whereas what Ian is doing is he's shrink wrapping. He's making the label for every vertex of the tree, every element of the tree. He's making it be the framed of its payload, shrink wrapped.
Right. And I think I think that decision is even made more based on the implementation of the behavior of that frame is an insert, right? So an insert doesn't resize, where for a graph, right, if it's a disk, right, it follows the normal behavior of a graphic. When you resize, it's resized based on actually the viewport or the window size. Right?
But if I wanted the behavior that Ian has if I wanted to implement tree with graph, how would I do it?
Right. So when you build so I believe the vertex shape function that are using by default in this case, which you draw the frame with the 2 inside, the third argument of insert should depend on the vertex size. Right now, I don't think it depends on the vertex size. It's probably fixed or automatic or such.
Yes, that's correct. And my claim is that if we made it depend on the image size, then practically speaking, every time you resize the tree.
No, I don't think it's the right thing. For trees, I don't think it's the right thing. I agree with you, because if you've put the payload in the label in that name there, you don't want it to get scrunched to nothing, probably.
I mean, you just can't scrunch it at all, I think.
Yeah, fine. I mean, I understand. But so what I'm asking is, is there a way, should there be a string name, for example, for vertex shape function that gives you this behavior for a graph? Charles.
A vertex shape function so that, yes, I mean, we can do that.
Well, it seems like a good idea to be able to get, because I've certainly wanted that plenty of times, where you want, I kind of want the two cases. One is a circle, one is a label in a circle, the other is a label in a rectangle, I think.
And I think in code, we actually, let's see, if you put in principle image scale, or you actually use a string scale, 1 and such, it will give you pretty much a similar behavior.
Can you send me the code?
I will try to write something.
Okay. But does it? Okay. So, okay, between Ian
I just also want to point out that trees uses rounded rectangles for non-leaves.
Yes. So you're saying reproduce that behavior as well?
If it's meant to be.
Yeah, I just want to understand how to do that. I mean, I'm okay. I mean, I would find it useful. I would have found it useful many times to just have a, vertex labels that are placed inside the nodes. The case which we have right now of placing it, exterior to the nodes is certainly useful. But I think this interior placement of the kind that exists in tree is also useful. And to be able to switch between those as easily as possible would be really nice. So, I mean, vertex labels arrow, and then something which says, do this enclosed label business would be good. I don't know whether there's a way to do that.
We introduce some plot theme like named label, where we actually do something similar, but not precise. What was that again? Well,
what do you mean named label? As in, but I mean, what happens if I just say graph?
Not name label, it's
if I say vertex label arrow foo, I believe everything will be called foo. So unless we have some special case here.
No. So what I mean, I meant the plot theme name label, right? And it does that.
Wait a minute, plot theme. There's a plot theme for graph?
Yes. We even have a meeting every time you forget that we have a plot theme for graph.
Well, maybe we need a graph theme. Maybe it should be called graph theme. Name label.
Labeled, yeah, LED.
Why doesn't this autocomplete properly?
You should actually. Okay,
that's the thing for Avery to go track down. But that's not what I wanted. I wanted inside the circles.
Can you take off the vertex label? I don't understand what happened there.
Wow, I forget it every time. As you say, Charles, I forget it every time.
What happens if you use a really large expression?
Yep, you'll get out of the circle, right?
Ag. See, why aren't we doing the thing with the rounded rects there?
Yes. So yeah, you requested that, so we are working with Tim on that. So you'll you'll actually feed the frame the size of the test.
Is this the most common case for plot theme to be able to do this? Is that the case one wants all the time?
No, I mean, it's depend of, the type of graph. I mean, at the end, it's not the graph, the size and the layout. So it's kind
Does
of
plot theme also change the layouts?
No, we currently don't change the layout.
Probably could.
Yes.
I do forget it every single time. And arguably it should be called graph theme. And how do we document this? Is it in graph?
Yes, it's at the end of the bottom of the details there.
That's incomprehensible. That's just frigging incomprehensible. That's frigging incomprehensible. Just show here that you say plot, theme, arrow, these things. Right? Plot, theme, arrow, theme. Possible forms for theme are blah, 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 blah. See what I'm saying?
Yep.
Otherwise, just incomprehensible. It's like you have to know.
What's incomprehensible?
What's that?
What's incomprehensible?
Okay. Graph feature themes affect the plots. Feature themes include. But then we see possible settings include common base themes, color feature themes, plot font feature themes, and size feature themes. And then we say this feature theme, it's just very indirect.
Right, but I mean, usually people will want to set, one of the feature themes, and then, they might want to tweak some settings with it.
Well,
right, you can specify multiple themes, right?
Then you should write that out. Plot theme arrow quotes theme, plot theme arrow list, this. Make a table of that. It's not comprehensible as you have it.
Sure, and it'd be actually great if we can rename that, graph theme and have a page and, document it more in detail and example.
What do you think? Do you think we should do that? I think we should do that.
Yes, especially now that we introduce for, we are introducing theme, right? For, I think it's data set and such, right? So that would be nice.
Right, I think we should do that. I mean, you've got to continue to support this one, but I think you should do that. But also, that documentation right there is just inadequate. Please fix it.
But I don't think that's different from how plot theme is documented.
Then
right?
That's inadequate as well.
Yep.
Well, take a look at plot theme.
Plot theme itself or plot theme?
Yes. It's the scheme we picked to document it. We can review it with Roger.
No, but this is better because it's much more explicit. That other thing was too short. It was incomprehensible.
It's
okay. In any case, it should be expanded. But let's not go there. Okay. So have we established where we were talking, Charles, before you got here, about when you specify something to be the plot label?
You mean shape?
Shape. And it's a picture of an elephant. And I kept on asking, where does the node position go in the elephant? In other words, the fourth argument to inset. Am I making sense?
Yes.
And how does that get specified? Now, maybe your placed specifies that. And how should placed work in trees?
It works.
So are you talking about so place is for labels, or are you talking about the shape, where the shape is related to shape function, the shape of a node? I'm a little confused there.
Well, I mean, in the end, one's going to draw something at the node, and it's a shape. You can factor that into a shape and a label. But in the end, you're going to draw something there. And I'm asking, let's say the shape is the shape of an elephant. And I'm asking, where does the coordinates of the node go in the elephant?
Right. So in terms of graph and vertex shape, right? The shape, it's, essentially is the centroid or the center of the shape, which match the vertex coordinate of the node, right?
But is that found by the bounding box?
Right. Yes.
Okay.
And because it's controlled by pretty much insert, right? And then it's the second argument of insert, where it's essentially the center, we match the center, right? Where for labels, we use place, and then the placement specification tell you where to place it.
Okay. Have you guys, Ian and Charles, have you looked through this list in detail and compared it to the graph case?
Not together.
I think you guys should. I mean, I may be missing things here. Because I think that there's some consistency that we need to check. Tree edge label. So that's the equivalent of edge label. So you've defined this notion of a tree edge here.
Mm-hmm. And so rather than being attached to an edge, since we don't have edges, this is the same thing. It's at a position and it applies to the parent edge at that position.
Say it again. I'm sorry, I got distracted by something here. Could you say that again, please?
Right. So you're not labeling an actual edge like in graph. You're specifying a label at a position. Same as with the tree element options, and it affects the parent edge of that node.
Because in a graph you'd specify it by the source and sink names on the edge. That's how you represent an edge. Whereas here, okay, so this is this the incoming or the outgoing edge?
So it's specified in the node containing 1. And so it's for the incoming edge to that node.
Why do you do it that way? Rather than the outgoing? Oh, I see, because there's a unique incoming node, but there are multiple outgoing nodes.
Yep.
Is that the argument?
Mm-hmm.
So if we go DAG at some point, then that will no longer work. Right? If we try to generalize this to DAGs, we could have 2 incoming nodes, could we not? 2 incoming edges. I'm confused.
I still think DAGs are just graphs.
The graph, I mean, yeah, we shouldn't, I mean, what you mean is that we shouldn't extend tree to that, I guess.
Yeah, all right, whatever. Okay, this, I understand what this is doing. Tree edge, it's a pity that it can't clue one in that it's the incoming edge in the name. You get what I'm saying?
Yeah.
Because that seems a bit unobvious to me. No, you see, this isn't good enough. No, this really isn't good enough. We can, oh, I see, as well as that of any subtree. So you're saying it's the label.
So same as with like style, if you just say red, it's for the root node, but you can also have positions matching a pattern and have styles for subtree.
Right, but this is basically the external label of a subtree labeled on its incoming edge.
Mm-hmm.
So I think it's got to say that more clearly, that this is, if you think about it as the label for the edge that feeds a subtree, that's what this is.
Right.
What would be a short name for that if we wanted to give us a short name? It would be
Is tree label too dangerous? Since it's
absolutely way too dangerous.
It's the whole subtree being labeled.
Yeah, it's too dangerous because it's also not clear that it's a label on halfway up the edge that feeds the subtree, so to speak. Anybody got any ideas for this? Itai, Christopher, anybody?
We want to call it like the root label because we already have our own. I'm trying to think of, within tree linguistics, would we say it's the stem label? I don't think we talk about tree stems anywhere, but or branch.
I don't think we do, but I think that the stem is a very good name for it in the sense that it is clear that that is the thing. The stem is not the root, so to speak. Well,
Branch. What about tree branch label?
no, because that doesn't get you the point. The stem, what's nice about stem is the stem leads to something. There's one stem, whereas a branch, there are many branches.
Okay, I missed something. Can we back up a bit? What exactly are we trying to name?
We're trying to name the thing that is the incoming. Okay, so the point is that wherever I've got an example here. Yeah, there we go.
Calling it the parent edge of the root node, which is not succinct.
Right. So here, the basic point is, what do you actually label here? Where is that label, the ONE, associated with? The answer is, it's associated with this subtree here. It is the feeder for that subtree. That's where the label goes. It goes onto the stem, which feeds that subtree.
I see.
And just saying it's on the edge is confusing because it's like, well, which edge? There are lots of edges here.
But right, it's right. You're right. It's not the edge, right? Because it's the thing that leads into the 1, 2, 3. Right. So theoretically, right. Can you give an edge label to 0? And would that just be sort of hover above 0? What would that do?
It wouldn't render until you used the tree as a subtree of something.
I see.
Okay. So this is, so tree edge label. That's simply invisible, which is rather confusing. And I hope you've documented that clearly.
I'll clarify it.
Yeah. This is a hard thing to name.
I think it should be called tree stem label.
Mm-hmm.
Tree stem shape function.
Yeah. Tree stem. This is the tree stem. This is the stem of the tree. And a root doesn't have a stem, I claim, which is why you don't see it. If you specified a stem label for that root node, it's just buried in the ground, so to speak.
Tree fertilizer label.
That's a more meta thing for the tree. It's not this is a tree which has grown.
Okay.
Not a potential tree. What do other people think about tree stem label?
What do you call the parent that contains a subtree? Do we call it parent, or is there some other term?
Yeah, the parent.
But this is the
not
thing.
Labeling the parent, right? Because it's not labeling the 0.
It's
Right,
it's
the parent
connecting
edge label,
edge
maybe?
to the parent.
Right. That's what I was
Or
gonna
from
say,
the parent.
edge label.
Yeah.
Oh, parent edge label.
That's the terminology I use in the notes, is the parent edge of the root node.
Well, but in principle, the parent can have many edges. I mean, it's kind of obvious you're talking about the edge to this particular child, but
right, because
still.
it's an option of the child.
Right.
Yeah, but you're right, that the parent edge, I see, it's the edge to the parent.
Exactly.
Right. It's kind of like analogous to source link in totally different
It is.
domains.
Yes, it is. It is. Parent edge label is not bad. I mean, it is nice, stem, you have to think a bit to realize it's an edge.
Mm-hmm. Yeah, I think I like parent edge label better.
Too. Yeah, I do too.
All
There other things? Yeah, we have parent tree, right? That's a thing.
How would that work?
No, we don't. That doesn't mean anything. What do we have? Do we have anything that is parent associated with trees?
We'll use the string parent when we get tree relative.
Okay, but I mean, parent edge label, What is parent list? What is that? Anybody know what parent list is?
That's a front-end option. So before we had the inherent associations and the inherent object, then you could set an option which set in a list which included parent list, which meant don't completely override the options from set at a higher level, add whatever's here to whatever is, the style settings that are set at the higher level. So that's what parent list is for.
Okay. But so are we bothered by the fact that there's a tree function that doesn't start with tree? I think not terribly bothered. Comments from other people?
Oh, I thought we were suggesting tree parent edge label.
I don't think so. I think it would just be parent edge label. What do other people think?
I kind of like parent edge label. I think it's good that it includes the word edge, because if someone is looking for something in the documentation, that's the keyword they're going to use.
Right.
I think pretty much all the other instances of using parent as a symbol name are related to that legacy front-end behavior. We have parent notebook, but otherwise,
Well,
it's
obviously, parent
language.
directory is something else.
Yeah, which is
but
also
it's
not-
very related, right? It's
Mhm.
conceptually, it's visualizing the file system as a tree.
Are we going to run into the problem with edge label again? That you might want parent edge label to work for things other than trees, but it might not be compatible behavior that you want in both cases?
Like a graph.
Yeah. Could work in a DAG
Yeah, only just.
notebook.
What's the edge label of a notebook? I think we should do parent edge label. I think parent edge label. Yeah, I think so. I mean, as I say, STEM is probably too whimsical and obscure. What do other people think about that? Do we kill STEM, so to speak?
I think so.
Okay. Boy, with all of this emphasis on, anyway, never mind. STEM. Okay. All right. Let's see if we can hit something else here. Are we done with these? Do you think, Ian?
We didn't look at style function or size function, label function.
We did look. Wait a minute.
Oh.
Style function for what?
There's tree element style function. There's tree edge style function.
Right. I thought we did look at that. Oh, we looked at style, but not style function. Okay. What is style function? Style function is not style because it is taking arguments that are what?
The data.
And what else?
That's it.
Why are we bothering with this? If you've got, look, in the case
this
of
is for the
trees,
use case of, you have style, I have a tree where lots of things have A, lots of things have B, and you want to have different styles.
I get it, but why, given that we've got to, in a tree, as opposed to a graph, we've got to use the pattern representation. We've got to use the rules to specify what the tree element style is. You can't just say tree element style are a red because it only affects one element. So you've got to say tree element style goes to, a blank goes to whatever, blah, 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 or all goes to whatever. So I don't understand why we need a function here.
Because this is what we discussed earlier. The rule is for a position spec, not for the data. This allows the style to depend on the data.
Do other people? I get it, but I mean, does that clear from the name? And is that the same usage analogy with? No, it's not the same usage analogy with graph, because graph
works directly with vertex names.
Yeah. Oh, I don't get it. Anybody else understand? Look. Vertex style, there's no vertex style function, is there?
Yeah. Vertex style.
No, it's not really needed. Like you say, right? We can use pattern rule 2, and then we apply that. So
Right.
we don't really need a function.
Right. So the reason that you need a function here is because the pattern is a pattern on the location, not on the data.
Right.
Right. Well, welcome to supplied, because supplied would deal with this. Maybe, wouldn't it? If the pattern involved supplied, if the value
supplied could be supported by style function.
And it could be supported by
the right-hand side could be supplied, and you could put in things like the position spec, and in addition to the data, and potentially other things.
Yeah, exactly. But that could be part of tree element style. It wouldn't need to be another style element.
But a supplied is not a style. Supplied is for functions.
Well, we haven't defined that. We've also said supplied can be the right-hand side of a rule.
No.
Well, we've certainly discussed that. We discussed the need for
the idea that we were discussing most recently for that was environment variables.
Okay.
Yeah, and all of that was going, well, maybe we should add this to the agenda for the next discussion of environment variables and supplied, which was going to happen today. So Devin or Avery, sorry, make a note of these last few minutes and copy and prepare them for me to add to that agenda.
Yep, I can do that.
I'm sorry, I missed the thing earlier. All right, so what are we going to do with this? Add it experimentally in this version?
I mean, everything tree related is experimental still, and which is good because we're still breaking things from version to version. So
yeah.
All right. Well, I mean, how do other people feel about this? Do you think it's okay? Or I think it's a little bit overcomplicated, and I think it can be ground down a bit. Ian?
I don't have an alternative way to do the task that you want.
No, I understand. I understand.
Style things based on the data.
All right. Well, let's put this in like this. Okay. Anything else to look at here?
Don't think so.
All right. Let's have a quick look at these other things. This first thing here that Danny is here for. Okay. What's this about?
So this is the discussion we had last week about position largest and smallest. We got into a bit of a quagmire with trying to figure out how to handle the second argument of position largest or smallest, because we want it to give back a rank, and the structure there is the information's non-trivial and it's useful, but the basic use case that we originally started with was give me the position of the maximum value and maybe just the first position of it. And Danny proposed that maybe we should just split this into two functions, one that is more descriptive and gives us multiplicity and rank, and one that just says, give me the position of the max value. Like we have first position already. Have an analog.
So what's the proposal here? You're saying position first largest and position largest or something? Danny?
Yeah, first position largest or something like that.
Well, you've written down here position first largest.
Okay, fine.
It seems like it should be first position largest, right? Because it's like first position.
Yeah.
Okay. But okay, so you're saying that would give the analog, I mean, first position gives. See, the problem is what happens if you want, okay, first position just establishes, oh God, it still gives it a list. Oh, that's because it's an actual position spec.
Yep.
What would you propose first position largest does then?
Yeah, it's put it in a list, doesn't it? Unless it takes a level spec. or unless it doesn't take a level spec. I mean,
What is the spec?
That was definitely Danny.
Yeah, no,
You're
I was
implicated.
implicated. That was my chair squeaking.
Okay.
Explicated.
The fair enough. Who needs video when you can get the audio postural data by audio? Anyway, never mind. That would have been a thing before video conferencing. Anyway, okay, so the issue is the case where you're getting, what is all this stuff?
Different function.
Okay, but what are you proposing for this other thing?
Well, what I'm proposing is whatever it takes to not derail this again. So last time, position largest got into this whole discussion of, well, most of the time what people want is just the first position of the largest element and it's unique, et cetera, et cetera. And that's not what position largest was designed or intended to deal with.
Okay, so what was position largest doing previously?
It's giving all the positions of the largest rank element. And if you ask for 2, for example, then it gives all positions in separate sublists corresponding to the 2 largest in rank elements.
The 2 largest families of elements.
Yes. Better way of saying it.
Okay, so I think one of the issues is, does that 2 mean just give me the first 2 in some lexicographic order of positions, or does it mean give me the first 2 families?
The latter, because
I know it,
you can already trivially do the other with take largest and index. We want something that is substantially more difficult to get without, us writing it in internal code, which is what I did. We don't want something that's trivial to get and serves no new purpose.
Okay, I understand. But so the issue is, if we do this, then when the default case of 1 in that second argument, we've got a heavily encrusted object. Right, that's the basic point here. This here.
Yeah, it's a double list.
Right, so the default case is not double, it's triple list. It's a triple list. What the heck is that? Why is position largest?
It's a nested list.
Okay, but why does position largest not work with 1 argument?
Because I didn't make it work with 1 argument.
Okay, but that will be the same as this, right?
Okay.
Is that correct?
Yes.
Okay.
Unless we want an operator form for it. Does it have an operator form?
I think it does, but I don't remember for certain.
Well, but it seems like the 1 argument case is way more useful.
Yeah.
I mean, it seems like if the 1 argument case can be used a lot more, then that's worth more than an operator form for a rather obscure multi-argument case.
Absolutely.
Okay, so the argument, so to speak, is remove the operator form if there is one and get it to work with 1 arg.
Yes, but now what you're saying is position largest.
Hold on, sorry. What do the layers of that list mean? So is the innermost list? Yeah, go ahead.
Each corresponds to a separate family in order.
So sorry, but I mean the list of 2 there, right? So is I mean, I guess it's the same as the one above, but like is the inner, so the 2 though is not part of position spec, like you get out of position.
It's
just a naked 2.
It's a pruned 2.
Correct.
Okay.
It's just an element. It happens to be a family with just 1 element.
I understand, but the main point there is that it's not a position spec.
Yes.
Wait.
That's because there's no level spec. Is that right?
Not sure, because I'm always confused by such things.
Yeah, no, I mean, this doesn't look great at all, right?
Well, it will be a triple list. That's the point. This thing here will be a triple list.
We don't want a triple list.
Yeah,
I know, but that's the whole point.
It's called indices largest.
But that's so totally obscure. Look, people are going to think of this as position largest. That's the name they're going to think of. So the question is, how do we deal with this encrustment? Yeah.
Right. So the first question is, I mean, I would argue that, okay, the layers of, there are three different potential layers of list. There's one layer of list to turn the two into a position spec compatible with like extract and position and so on. The next layer of list is the there's a family of ties.
Yeah, ties.
Then equal size. Then the third level of list is I asked for the top 3 tying families, right? I would argue that the last one is a niche thing. I mean, I understand that part of the reason it's there is to differentiate it from take largest, but I think it's just not that common. And adding an extra layer of list for it in all cases, when 90% of the time, you only want the number 1 family.
So you're saying get rid of that argument entirely?
Well, that's the second argument. Have it be a one argument function and just not return the family.
I myself don't think that's the right thing to do, but I'm willing to do it. I would check with Gosha though, since this kind of is in the take largest family, and we
okay, but hold on. Is there any way out of this? Could we? It seems wrong to have the default case. I mean, there is a hacky way out of this that we've used for some functions. Like cellular automaton uses this, which is that the default. Okay, this is Hackola.
Right. There's no default argument. There's no default value for the second argument. The default.
No. We could have the default value be this.
Oh.
That's what we've done in some other cases.
Now, tell me what exactly that means. Because
it means
the opposite of what's intuitive based on the way it's written.
Do not pretend that this is a level spec, because this function will not take a level spec. It's not. That's something that's way outside.
I know this is a family pruning
different. Spec. Right. Okay. That's yet another reason why this syntax is bad. I mean, it's already used for cellular automata. So with cellular automata, when you give it the number of steps you do, if you just say like run it for 10 steps, it'll give you the first 10 steps. If you ask for like list of 10, then it will only give you the state after 10 steps with no extra lists around it.
You realize exactly how horrifying that sounded.
There weren't that many lists. There was an exaggerated number of lists there, but it isn't wonderful.
I think there is actually behavior at 3 levels.
This is a hacky, weird way to get to what's not so bad, is that if the one argument form gives things that are 1 level less steep than the 2 argument form. And if you need a 2 argument form that represents the 1 argument, use automatic instead of this list 1 thing.
Yeah, well, that might be right.
That's what I thought you were going to suggest. Yeah.
That's not so terrible.
Yeah, I kind of agree. Because you've got 2 arguments there. It's hardly as if you don't know that you gave 2 arguments.
Exactly, right.
So run that back, Bob.
Okay.
So the 2 argument form is exactly what you have, I think, except unless we want to make them proper position specs. I don't know about that. But the 1 argument form is the same thing as giving it 1 and then sequence at, basically. You drop the outer list. Because
okay,
maybe think of it as first instead of sequence at.
Yeah, first, sure. First.
Okay, so that would be a case where you're just giving a singly nested list, a single list of integers, basically.
Right. Because it's always length 1 when it's in the 1 argument.
Wait, but no, aren't we still actually given positions?
Well, that's another question.
This is assuming we don't switch to position specs, which is the second.
Right. So in this list of 3 different levels of list we have, we're basically saying that the third level of list, the families level, is only included in the 2 argument form. And the 1 argument form, it just calls first and it just gets rid of that whole level of list.
Well, I think we've got to give position specs. I don't know. Can we get away with, even though this is a 1 level function, even for first position, there is an argument. I mean, that will be a first position function that just gives naked indices.
First position does take a level spec.
Okay.
Yeah, I believe it does. Yeah.
I mean, each of these is a part spec, right?
Right. So
if you did part of list 2, you would get just the second one. If you did part of the list 8-3, you'd get the 8th one and the 3rd one.
Right. I mean, I feel like the problem is just that is more that it uses the word position, right? And every other position function gives extract specifications.
Right. And this isn't.
Right.
So you're right. And I object to something being called position blah when it's not giving positions, right? I mean, I did not understand that this only worked on flat lists.
You would prefer part largest?
Sure. Or index largest.
I think somebody suggested that.
Index largest is just really, really, really obscure.
Mm-hmm. I guess the question is why is it important that we strip out the outer list for, you know, not have these be, I mean, I guess this only works at level 1, but
the position spec level of list.
Yeah.
Well, because the minimal case then is this, right? This is then, although that list comes from a different source than the source we're talking about here.
Mm-hmm.
That says that the minimal thing, if I in this thing here, that tie, the 8-3 tie there, it's going to look like this. The minimal case is going to look like 8-3, like that.
That's if you strip a level.
That's if you strip the family level.
Yes.
Right. If the one argument case of the function. Yes.
Just to throw one minor monkey wrench in here, we do actually have a position named function that doesn't give position specs, and that's position index gives part specs for the
position index.
But I don't think anyone uses position index.
Why did we call it that and not index position?
Also, map index takes a position.
Right.
What is position? What is position index?
Position index. Yeah, I do.
Is this a Taliism?
It's the one that makes an association of it tells you where things appear in the list.
Wow.
This is actually, I think, a pretty useful function.
It is a useful function, yeah. But its notion of position is naked position numbers.
Right.
Yeah, I don't suppose naked position largest is going to cut it. God, I wonder what the SEO would do for that.
That's
I have
in chat. That's the behavior that I would think makes sense for position largest, returning position specifications, and you can give a level just like position.
Right.
Yeah, that may indicate that we have the wrong name for the function. I don't think we really want to go with specs, level specs.
What the heck does a level mean? Because you've got to be comparing. Listen, there's only one level at which you can do comparisons. Because typically with most comparison functions, by the time you've got a higher level, it's very unlikely that the comparison function is going to work.
Well, no, I mean, you could imagine doing it at level 2, like level list 2, right?
Yes, but
what's
then
the
you couldn't do it at level 1.
Matrix.
Yes, you could do that, but then you couldn't do it at level 1.
Right.
I guess so. What?
Well, what do you mean you couldn't?
Well, because you've got a bunch of vectors you're comparing.
I mean, if somebody really wants to do that, they can either use map or, define a custom function for doing the comparisons.
Yeah.
Depending on what exactly they want to do.
Right. I mean, but yeah, I mean, also, I think we definitely, to go back to the earlier statement, though, I think we definitely do not want this function doing crystal ball magic to figure out, oh, you gave me a matrix. That means I should actually be
it's completely crazy.
At level 12, right?
No, it's not going to do that. No.
I understand
I mean, having it, being at array depth of -1 is a perfectly sensible thing. Now, I suppose
what if I don't know, I don't know too much about how array depth works, but what if, for example, you have a ragged array? Does that suddenly mean that the array depth is higher?
Array depth is only, the raggedness
breaks the depth.
Your comparison function, and I haven't talked about this and it's not documented, but you can give it a optional comparison function like length. Well,
Which is
you'd
the
have to,
third argument, the comparison function.
yeah, it would have to actually be rigged slightly, ordering of length of / or hash or whatever.
Right. Well,
Length
I
of
mean,
hash
right.
one greater than
Right.
hash two.
Right. But
Yeah,
right.
thanks.
But if you used, say, yeah, well, I suppose if it's always doing things at level 1 and you have a matrix, right, then you could give it vectorless or something.
Yeah.
Right.
Yeah.
Maybe just one other point. I mean, just because we mentioned position index, I have wanted the like level 2 version of position index, but of course it can't have it because of this problem that it uses positions instead indices instead of positions. So just for what it's worth. I mean, as in this function, maybe one day we'll want to give this function a level spec 2.
Yes. And then we would have to have it do this thing about having different forms for if there's a level spec.
Right. And of course, I mean, the thing is, if you do give that extra level of list, for position specs, it's slightly annoying, but it's very easy to get around. It's just part all comma 1 or something like that. But
yes,
the converse is impossible, right? If it doesn't give those, then there's nothing you could do.
I have a name to propose about location largest.
no,
Doesn't carry any position connotation.
no. No, I mean, then we've got a whole giant family of locators, so to speak.
All right.
Locator.
Right. Yeah. So Richard put in chat basically what would be my intuition about what a position largest does. I mean, irrespective of what its the default level is, right? You basically get positions at a specific level and then you extract them and compare them. Which
I don't think
basically
that's the function we want.
Well, right. I mean, but maybe another way of framing this function that Richard has here is it's position, but without the second argument, the object that you're looking for spec, and the implicit object you're looking for is just max of, at the correct level and so on.
Yeah, I don't think this is the function we want. I think the function we want is the one. I mean, there is this question of what exactly the return type should be, but I think we want something that looks at a single list or at the level 1 of whatever it's given.
Look, if we're doing the elision for families, we can do the elision for levels as well.
Well, I mean, with levels, you can just map the thing.
No, I'm saying, you mean to get different levels?
Yes.
Does that work?
Well,
no,
you can make it work.
No, but if you've got
you can't,
one corner.
If you got the max of if I have a matrix, and I know the max position in row 1 is 12 and the max position in row 2 is 15, I don't know which is the max of the whole matrix.
Yeah,
maybe I'm not understanding. Oh, you're trying to find the max of the position of the max.
Yeah, the IJ
Got
position of the max.
Got it.
Okay, so look, it seems to me once we cross the bridge of eliding a list, and particularly given the future potential for enhancing position index to have a level spec, I kind of think that the right thing to do here is to have position largest, not return the family list by default. And I'm kind of thinking not return the position spec list by default.
Now, okay, because the thing about that is I think that would actually be quite useful, but it's also horrible, it would also have been quite useful in position, which of course doesn't do that. So
yeah,
it's sort of, well, actually, no, sorry, because the default level spec for position, isn't it some infinity head 0 true or something like that anyway? So actually, never mind. The default can't be that. But I think it's kind of wrong that it's infinity head 0 true. But that's a different issue.
Well, I mean, we could conceivably have a function list position, for example, that just gives the thing you want 99% of the time, which is the position of something in a list. And we could, as an extension, we could allow it to do some other function thing. But if we had list position, which I agree would be, I agree because I've wanted this a gazillion times.
Yeah, I mean, with position, I do like every time I use position in like quote unquote real code, like in robust code, I always feel guilty, and then I have to put all this head 0 false, level 1. It's
Maybe
very
we should
like,
have a thing called list position that just does that thing. Just gives you the position of something in a list. That's it.
There's 2 arguments.
Yeah.
And it's
Maybe it takes
we'll
spec.
put one to position at level 1 with the heads goes to false.
That's correct. Just
So that's a one-liner in terms of implementation,
yes,
because that's
Yes,
how
it
we would implement it.
Yes.
Okay. Sure.
Danny, don't say first list position largest.
First list position, largest. Yeah.
right, maybe we
Bye.
need to make one of those tables of, oh, well, we've covered this functionality, so now we need to have, fill this gap.
Oh, no, not the E-tie table.
I think that was actually my table.
Oh,
all right. List position, I think we should consider. I've wanted something like that for forever. Now, position largest, I kind of think we should go ahead.
Well, I'm just going to say, if we're going to have a list position, then maybe we should have, this should be list position largest.
Yes, it could
that's
be.
not a bad idea.
In which case, okay.
But maybe also, I mean, I feel like, okay, well, it might still, I think it is still somewhat useful functionality if you can get the max position of a matrix.
Separate. So wait, hold on.
That's crazy to have another function for that. I mean, position largest. The question is, how bad do we feel about the thing about, drop families? Okay, so the idea would be that the default structure of position largest is automatic or something, or automatic, I don't know, none or something. And that none is a level spec that means just don't use levels and therefore don't return the position. Like, I mean, that's an interesting idea for other functions. Actually, that is an interesting idea. Okay.
No. I think the third argument would be list 1, and it's the automatic that is saying, I just want the first thing without having an extra layer of list.
No, but I think the point is, if you say list 1, then you have to return it has to be consistent with list 2 and list 3, and that it returns a list for each position spec. Right. The point of writing none is that it's not even going to return a position spec. It's just going to return a naked.
I'm saying it's the second argument controls whether you just take the first, the list for the first rank, or whether you have a list of lists for each rank.
No, but we say the second argument is the family. The third argument is the thing we're describing as the position spec. Okay, so I think the interesting idea here, which just occurred, is the idea of a none level spec. Okay, because we could even imagine that for position itself.
What does that mean?
It means.
Are you talking about the input or the output, Stephen?
I'm talking about the input. I'm talking about the input. So here's what I'm suggesting. Okay, so what I'm suggesting is, it's a little weird, perhaps. I'm suggesting that in the case here, if I say this position of that a comma none, okay,
That's
suggesting that. What's that?
None as a level spec.
That's a level spec, yes.
You should, to make this example clear, you should make put 2 A's in the list. Otherwise, it's ambiguous what you're about to write.
Yeah, okay. So what I'm going to say is
that returns the list 1, 3.
Okay.
Right. That is not crazy, in my opinion.
I'm hard pressed to understand how this operates as a level spec.
The whole point is, there is no level that we're talking about. We're just looking at the top level, and we're going to ignore it's a way.
It's level 1 with a different output type.
Okay.
Basically, yeah. I mean, I think that the point of this, I'm still not totally sold on this, but I mean, I think it seems like the point of this is just that there are a bunch of functions that, for the sake of generality, return position specs, but where a lot of the time you're just giving it a level 1 list.
Right.
And so, it would be nice if you didn't have to write all these extra list things around them.
Okay.
I think it's an interesting idea to have a maybe none isn't the right thing, but to have a named level that is an unpeeling level, so to speak, that says don't give the explicit position. Well, it has to be something like none, because it's only going to work at the first level.
It's basically saying if this function were if this function were a function that didn't accept a level spec, what would you
what would you want?
What would you want? Yeah.
Well, I mean, part of our problem is not does it accept a level spec for position largest, I mean, but the naming, the fact that position is in the name.
Okay, but listen, I think a study should be done of other functions that have a level spec and whether this none idea would be useful for a bunch of them.
Yeah, I can take an inventory of those and see where we're going to run into issues at least.
Well, another question is if there's separately this idea of position list. I mean, maybe this replaces position list, but
list position
or list position. Although list position would also have the head 0 false and stuff, and the different default. But I mean, if we had this, is there a reason not to have list position take 2 arguments, and its default is none, head 0 false, but it can take other things, and I mean at that point it's basically just a replacement for position.
Yeah, that gets it gets a little bit confusing, but also there's the question of is it worth it? Given confusion.
Right. We need to look at list position versus looking at a none argument for position, which I think is probably a more general approach.
It's more general, but I think that I think that's the right thing. But also, just as a note, I mean, if we had this concept in version 1, then I would argue position should have different default settings, but that's a different issue.
Probably so. Yes. But it's a no time machine problem.
Right.
What does automatic mean in this setting if none is the one that strips?
Strips the position spec.
Yeah.
Automatic is the one that strips the family list.
Well, but maybe by the same logic that we chose none instead of automatic, maybe it should be none again.
I see what you're saying. That makes sense.
So this automatic, as it is now, we would simply return a single list of integers, and those integers would correspond to the top the top family positions, top rank. Yeah.
Right.
Okay.
All right, let's examine this none idea, which should have been an idea 30 years ago, or whatever, but it just only was discovered. That's the nature of these things. Let's examine that as a possibility and other things, and then till we go from that. And maybe this becomes position largest of the list common none as the default. Make sense?
I'm not sure about that the first none, the second argument.
Yeah, I agree. I think it might be better as automatic.
Yeah. Yeah,
right.
That has a clear, unambiguous meaning.
All right, let's have a think about this. Have to think about that none thing, and we should probably wrap up for now.
Okay, so Nick, you're going to look into some of that.
Yep, I'll do some of the inventorying.
Okay, and I gather Itai is supposed to stay for something else here.
Okay, and Nick, you'll let me know what you find out, and that'll give me some idea of what to do with position largest, at least.
I think we're very close on position largest. There's only a question of how these defaults work.
Okay. I'm a little bit less clear on the idea of how we're going to retrofit, but using it in position largest, I understand now.
Right. I don't know how the retrofit works.
Okay, so Nick, I'll follow up. You'll follow up with me, and we can At least I can get it into position largest in the next, I don't know, week or two or whenever. This is not for 13.1, I assume.
I don't think it can be.
This function. Okay, so I'll try to, we'll try to work this out, and maybe I can put it in after the code freeze so it won't go into 13.1.
Yeah. Sounds reasonable to me. Anything else for right now? Nope. Okay. Thanks, guys. Thanks.